Okay guys, let's take a look at the lesson today. This is Logistic Growth Day 2. If you recall, in Day 1 we just looked at like the first derivative and the second derivative, and we learned what they could tell us about the position, but we didn't really deal with the position yesterday. Today we're actually going to find the position of this logistic growth. So the first example it says, or actually the only one we're going to be working, the rate at which the flu spreads through a community is modeled by the logistic differential equation, and it gives us the equation, whereas t is measured in days. So they give us initial condition: if p of 0 equals 50, solve for p as a function of t. All work must be shown. So what they're asking us to do is solve the differential equation. So that what that means is we separate the variables and then we integrate, just our regular solve the differential equation thing. So let's do that. I actually, instead of the 0.001, since I'm going to be working with it, I would rather it be a fraction. So I'm going to rewrite it first in fraction form. So we have dp dt equals 1 over 1,000 p times 3,000 minus p. Okay. So at this point I'm going to separate. I'm going to move the p's over to the left. So dp over p times 3,000 minus p equals 1 over 1,000 dt. So we integrate both sides. Now the reason that we had to wait to do this lesson until after partial fractions is because this particular type of formula, the logistic growth, requires partial fractions to integrate the left side. Now the partial fractions are actually pretty easy, and they're formulaic. They look the same every time, and so it's not a real difficult partial fraction thing to do. I'm just going to walk you through it. So what we would have, I'm going to just work it over here. So we would have a over p plus b over 3,000 minus p, and that's equal to 1 over that whole fraction. So if you recall the technique, we multiply through by the denominator to wipe out all the fractions. And so what I end up with is 1 equals a times 3,000 minus p plus b times p. Okay, I'm not going to distribute there. I'm just going to kind of distribute in my head. Hopefully we're okay with that to set up our equations, our system of equations we need to solve. So we don't have like a p over here, so 0, coefficient 0 is going to equal negative a plus b, and it's virtually like that every time. It's every time. That's it. 0 equals negative a plus b. That's your first equation. The second equation is just almost virtually every time 1 equals, and my only constant here is that 3,000 a. So I solve for a, and I get a is 1 over 3,000 and b is 1 over 3,000. Again, that pattern follows virtually every time. It's usually they're the same, right? Because our first is negative a plus b, 0 equals negative a plus b. So that's really a constant, and instead of putting each of these, on each of the fractions here with the a and the b, I just pull it outside of the integral so that it's just a little bit easier to work with. I'm going to just do that down here, 1 over 3,000 integral, and so I have 1 over p plus 1 over 3,000 minus p dp equals 1 over 1,000 integral dt. Since I have an equation set up there, what I like to do, if possible, is deal with those messy fractions. It's an equation. I can multiply both sides by 3,000 to move the 3,000 over, to move this over to the other side and make it a 3. That's really way easier to deal with than the 1 over 3,000 and the 1 over 1,000. So that's what I'm going to do. I'm going to multiply both sides by 3,000, and I'm going to be left with the integral of 1 over p plus 1 over 3,000 minus p dp equals 3 integral dt. That's going to be just a little easier to work with. So at this point we would integrate, and we know these integrals pretty well by now, I'm sure. Natural log absolute value p This one, the second piece, I'm actually going to have to do a little baby u sub in my head because the p is negative. So it's actually going to be negative natural log absolute value 3000 minus p. Again, I'm going to wait to do the c on the other side, on the right side, so I get 3t plus c. Okay, we okay? Alright, so now we need to solve for c. I'm going to use a log rule to bring these together into a fraction. So we have natural log p over 3000 minus p, and that's an absolute value, equals 3t plus c. Alright, so we're going to use this. When t is 0, p is 50. So I have natural log of 50 over 3000 minus 50 equals c. Right, because the t was 0, so that went away. So simplified, that's natural log of 50 over 2950, which reduces to 1/59. So c is natural log of 1 over 59. Okay, and there's our c. So this process should seem familiar. We've done this before. It's got some crazy numbers. It's a bit algebra intense, but it shouldn't be anything unusual or strange. Are we okay? So if you recall at this point, I'm going to put the natural log, this c, I'm going to put this c back in. So I have natural log of p over 3000 minus p equals 3t plus natural log 1 over 59. Okay, and at this point we want to solve for p, which is going to be a little bit more intense than normal because we have two different p's. But it's not going to, it's just some algebra. It's algebra heavy. But we probably have a lot of algebra lovers in here, so I'm sure it's fine. All right, so here we go. So we're going to translate. So it'd be e to the 3t plus ln 1 over 59 equals p over 3000 minus p. Okay. So from experience, past experience, we know that this plus ln 1 over 59 is going to turn into the coefficient of this e. Okay, so I'm not going to go through that algebra. I'm hoping we're all fine with that. This is going to turn into basically 1/59. 1 over 59. And I'm going to put the e up here. E to the 3t. 1 over 59 e to the 3t equals p over 3000 minus p. The reason that I want to do that is I want to make it clear that I'm going to cross multiply here. I'm going to do the 59 times p and the e to the 3t times the 3000 minus p. I'm going to do a cross multiplication. So I have 59p equals e to the 3t times 3000 minus p. And we get to come up here. So now we distribute. We know we're going to have to distribute this to both. So I have 59p equals 3000 e to the 3t minus e to the 3t p. We want to get the p's on one side of the equation and then factor them out. So I'm going to move this term has a p in it. I'm going to move it to the right, to the left. It's negative over here, it'll be positive over there, and I'm going to factor the p out at the same time. I hope that's not too troubling. I'm going to do two things at once. I'm going to move this and factor out the p. So I have p times 59 plus e to the 3t equals 3000 e to the 3t. Hopefully we see the light at the end of the tunnel. We are almost done with this. And we have p is going to equal 3000 e to the 3t over 59 plus e to the 3t. Whew. Fantastic. That is part A. Yay! I know the looks on your faces. How are we doing okay? I know it's algebra intense. I understand. It's really algebra heavy, but doable. Right? It's doable. Okay. So once we get the equation, the rest is pretty easy. Part B asks us to use our solution and our calculator to find the size of the population when t equals 2. Well, that's pretty straightforward. We just we take our equation and we put a 2 in for t, so that would be 3000 e to the 6 over 59 plus e to the 6. And we just put that in our calculator and we get 2617.238. But we realize and understand that we're talking about people, right? We don't have a portion of a person, so we truncate. So our answer is 2617 people. Okay, part C says using our solution, again we're going to use the equation that we found, using our solution and our graphing calculator, find the number of days that have passed when 2,400 people have contracted the flu. Okay, so that means we do 2,400 equals 3,000 e to the 3t over 59 plus e to the 3t. Now, since we're allowed to use our calculator, what I would do, and what I did, is I would put the 2,400 in L1 or Y1 and this fraction in Y2 and just intersect them. And that would be my answer. I mean, that's how I solve on my calculator. I know there are other ways, but that's the way that I like to do it. I like to go the graphing part, you know, Y1, Y2, intersect them. And when you do that, you're going to get a t-value of 1.821 days. And there is our work on finding the position and answering questions about the position. How's that? 1.821. 1.821 days. All right, is everybody okay? Okay, so now for the new slide that I added just this year. Does anybody still need anything? Okay, so let's move on. So after many years of teaching that, I actually love that lesson because, you know, I'm kind of I don't know, I love algebra too. I thought, well, I'm going to show you a different way to get the position. Okay, now this way involves formulas. The first way doesn't involve any formulas. You just separate, you know, solve your differential equation. This way is going to involve formulas. Now, this way is much faster, of course. So let's just talk about the dangers in both of the ways. The first way, the danger is getting lost in the algebra, really, and making a sign error or something. The danger for this technique is to forget the formula, because that's really the danger here, is or maybe you get it mixed up. Maybe you get the letters mixed up or something. But what we're going to do is we're going to generate the same formula that we did on the first page using this technique. Okay, and then you decide which technique you want to use. It doesn't matter to me which one you want to use. Whatever you want to use. Either one is fine. So let's go ahead and talk about these formulas. This first formula is the logistic differential equation, which we've talked about at some length. And remember, it needs to be in this format because you read K and L out of this format. Okay, those are two important quantities that you need to know. So it needs to be in this format right here. The second equation is actually the equation for the position of a logistic differential equation. This is it. It's going to be that every time. These formulas work for all the logistic differential equations. Okay, so it's going to work. And notice the things that I need for my formula. I need L, which I'm going to get out of my differential equation. And I need L actually twice in two different places. I need K, which I'm going to get out of my differential equation. And I need A. That's the only thing that I can't get out of the differential equation. It is another formula. A is created by taking L, our limiting capacity, and subtracting the initial Y value divided by the initial Y value. Okay? So that's the way this works. And we're just going to work this through and get the equation. So the first thing I'm going to do is we're going to use A. So A equals. So L, we read right out of this. This is L, is 3,000. So 3,000 over, 3,000 minus Y naught. Let's see, that's this, is 50 over Y naught. So 3,000 minus 50 over 50. So A is going to be reduce, we subtract and reduce, we get A is 59. Okay, so that's my A value. All right, so let's go to our equation. So P equals, so L, I read out of here, is 3,000 all over 1 plus A is 59, and then it says E to the negative, K is 0.001, L is 3,000, and then T. So we pretty that up. We get 3,000 all over 1 plus 59e to the negative 3t. Now this formula looks different from the formula that we did on the previous page, but it is exactly the same. So I'm going to do just a little bit of algebra to show you that it is the same formula. Doesn't matter to me which format you use. So what we would do to make this look like the one on the other page is do a little bit of algebra. So this is e to the 3t. So I would find a common denominator here. I would get 3,000 over e to the 3t plus 59 over e to the 3t. Okay, this is the main fraction bar right here. So I fix my complex fraction, and I get 3,000 e to the 3t over e to the 3t plus 59, which is exactly what we got on the previous page. Okay, so now that you've seen both techniques, you're just going to have to decide which one you want to do. They both have some dangers. Just decide, which path you want to choose, and there you go. Okay, so you have a choice. Okay, any questions?